Hello. This video is just like the previous one where we discovered or where we talked about 45, 45, 90 triangles, except this time we're talking about the special triangle that is 30, 60, 90. Okay. So just like the 45, 45, 90 triangle, this one is derived from a shape. It is derived from an equilateral triangle. So let's think about an equilateral triangle with side lengths 2x, 2x, and 2x. Now an equilateral triangle is also equiangular. This is going to be 60. Let's put it inside. This is going to be 60 degrees. This is going to be 60 degrees. And this is going to be 60 degrees. Okay. So if I dropped an altitude, right, it would bisect the bottom. We would now have side lengths of x and x for each one of those triangles. It would hit at 90 degrees, and it would cut this 60-degree angle up here into, 30 on this side and 30 on this side. Okay, so if I split off this little triangle over here, it would look like this. Oops. I don't know what this one is called, but let's just call him B. So I've got 60 down here and 30 up here. Okay, so I have x squared plus b squared equals 2x squared. This is going to be how I solve for b. So I've got x squared plus b squared equals 4x squared. I get b squared by itself. B is equal to x times the square root of 3. So the ratio of sides in a 30, 60, 90 triangle are x to x square root of 3 to 2x. And so if you have a side, you can generate the other side lengths using multiplication or division to bounce from side to side. And that's pretty cool. So let's look at the side lengths that are created when you have a unit circle, right? So we have it's fine. Okay. So we have a triangle that's going to look like this. It has a radius of 1, right? And theta, or the angle, is going to be 30 degrees. And then here's our 90-degree angle, okay? So if this is going to be side length 1, we can find the length of all the other sides of this triangle. I'm going to erase the R so it's not confusing. Again, the ratio of the sides are going to be x to x square root of 3. Sorry if you hear my dog snorting in the background. She is wild. Okay, so we know that the length of the hypotenuse is 1. This 2x here is always corresponding to the hypotenuse, so I'm going to put a 1 down here, okay? Now we have a tiny little equation that we can solve in order to get the rest of the sides. So I've got 2x equals 1. Divide both sides by 2. X equals 1/2. So x is 1/2. This side is 1. And the structure of the ratio of the sides tells me that this side here is going to be rad 3 over 2. So I'm going to go ahead and put these onto the triangle. I've got rad 3 over 2 down here, and I've got 1/2 over here. Why is that one 1/2? Because remember when we derived it up top, 1/2 was the height, and rad 3 over 2 was corresponding to that side length there, okay? So, cool. Why did we do this? What does it tell us? Well, we can use the fact that x is cosine, y is sine, y is sine when we're looking at the unit circle. And let's say we wanted to know what the sine of 30 is. We can look right on the unit circle that we just made and figure it out. However, we are working in, actually, let's do degrees first. Okay, So we've got the sine of 30 equals 1/2. Why? Because opposite over hypotenuse gives me 1/2. Cosine of 30 is rad 3 over 2 because adjacent over hypotenuse gives me rad 3 over 2. And the tangent of 30 is going to be 1 over the square root of 3. I would rationalize that guy. And I would get rad 3 over 3. Okay? So now, since we are in the unit circle, we are no longer going to be thinking in degrees. We want to think in radians. So I'm going to take that 30 degrees and I'm going to multiply it by a very smart rewrite of the number 1, which is pi over 180. And now I have pi over 6. So 30 degrees is pi over 6 radians. So I'm going to rewrite these as the sine of pi over 6 equals 1/2. Cosine of pi over 6 equals rad 3 over 2. Tangent of pi over 6 equals radical 3 over 3. Okay. So now we're talking in the unit circle, and we have all these really cool trig ratios. They are very common, and these need to be memorized. Just like the sine, cosine, and tangent of pi over 4 need to be memorized, these need to be memorized as well. Okay. Now, I personally challenge you to use the same idea from above to calculate. So here, let me write out the challenge. Excuse me. Ew. Calculate the sine, cosine, and tangent of 60 degrees. Don't forget to convert it into radians after you've found the sine, cosine, and tangent of 60 degrees because we're dealing with a unit circle. Let me give you the picture before you begin. So we have our unit circle. We have a radius of 1. We have a 90-degree angle over here, and theta is 60 degrees. Okay. So using the ratio of sides for a 30, 60, 90 triangle, I want you to fill out what this side length is. I want you to fill out what this side length is, and then I want you to figure out the common trig ratios for 60 degrees. Okay, so we would have sine of 60, cosine of 60, tangent of 60. Go ahead and pause the video, figure it out on your own, and then unpause the video when you're finished and check your work with mine. Okay? So go ahead and pause it now. Welcome back. Let us check the work here. Okay, so I'm just going to put it up here real fast. We got 1/2 rad 3 over 2. You should have converted it to radians. You should have gotten rad 3 over 2, 1/2, and rad 3 over 2 divided by 1/2, which would give you radical 3. Sine of pi over 3 equals rad 3 over 2. Cosine of pi over 3 equals 1/2. And the tangent of pi over 3 equals radical 3.